Hi, I'm George Hart. I love to make geometric things that show the beauty of mathematics. Today we'll make a very basic structure that I love, but which few people know about. It's really beautiful and elegant, so I want you all to know about it. But it can be confusing at first to visualize. The best way to come to understand it is to make physical models. I'll show you two different ways to construct it. First from paper, scissors, and tape, and then again from pipe cleaners. It's a challenging puzzle to assemble, so don't assume this will be easy, but once you get it, it's really cool. The structure is just 4 triangles. The first thing you think of when I say 4 triangles is probably a regular tetrahedron. That's just our name for this pyramid with a triangle base. This is a fundamental symmetric structure made of 4 equilateral triangles. Any 2 triangles join along a common edge. What's surprising is that after thousands of years, mathematicians discovered a different elegant symmetric structure made of 4 equilateral triangles. The triangles don't join along the edges. In fact, they don't touch at all. They float around each other so that any 2 triangles are linked, like 2 links of a chain. Let's make it first by cutting and taping paper strips. Print out this template onto cardstock. I recommend 1 sheet each of 2 different colors. If you don't have cardstock, it's okay with regular paper, but the heavier weight of cardstock is much better for this. First, cut each sheet into 12 strips. Just cut on the solid lines, so you'll have 12 white strips and 12 blue strips, or whatever colors you have. I'm going to call them white and blue. Next, we'll pair together a white strip with a blue strip. They're not perpendicular. It's about 20 degrees rotated from that. The angle is shown with the dotted lines, making a rhombus in the center of each strip. Just put a white rhombus together with the blue rhombus. Look at it from both sides, make sure they're aligned, then tape them together. You can tape it on either side, it doesn't matter which. So you're making 12 X's, and each X combines a white strip and a blue strip at this angle, which is about 70.5 degrees. Now, we're going to fold just the white strips into little triangles. We're going to fold them back sharply at the 1/3 point and the 2/3 point. That's indicated with dotted lines. You can get a sharp crease quickly and easily by bending them over the edge of a metal ruler. Now, tape the little triangles to hold them closed, and we'll have 12 modular units. Each unit has a straight blue strip and a white triangle attached at an angle. Now comes the final assembly. We're going to end up making big blue triangles. Inside each corner of each big blue triangle will be a little white triangle from another module. Start by attaching 2 blue strips over a white triangle. Then complete those 2 sides with a 3rd module. Whenever you join 2 blue strips, you need a white triangle underneath from another module to support them. Here's 1 blue triangle. Note that the little white triangles always point to the outside. Then keep doing the same thing. Complete any strip into a triangle. When everything is all connected, you'll end up making 4 big blue triangles, and there's a little white triangle inside every corner. It's amazing how everything joins up to something. The result may take some time to appreciate. 4 triangles. Every pair is linked. It's nicely symmetric. You can stand it up on 4 points, so every triangle touches the ground, and there are also 4 points on the top. Or you can stand it on 3 points, so 3 triangles touch the ground, and there are 3 points on top, and the 4th triangle is horizontal, midway up in the air. Play with it. Get to know it. See if you can shut your eyes and visualize it as clearly as you can visualize the 4 triangles of a tetrahedron. Here's an observation to help you understand it. You can place it with 4 points on the table, so there'll also be 4 on top, and you can rotate it so there are 4 points in front, 4 in back, 4 on the left, and 4 on the right. So it lines up with an imagined cube. Visualize that, and you'll see each point is at the center of one of the cube's edges. That's how we'll make our second model of this structure. I think this second model is even nicer. We'll use 2 colors of pipe cleaners, white and blue. With the white ones, we'll make a cube as scaffold. Then we'll add the blue pipe cleaners as the edges of the 4 floating triangles. For this to work out, you need their lengths to be in the right ratio. I found 12-inch pipe cleaners in a local store, so I'm going to cut 6 blue ones in half to make 12 blue pieces, each 6 inches long. These will be the triangle edges. Next, I'll cut out white pieces to be the cube's edges. These need to be shorter. 5 inches works well. Cut 12 white pieces, each 5 inches long. Start by making a white cube. 3 white pieces meet at right angles at every vertex. You can just fold over the ends to join them. Fold the same distance everywhere, so the central part will always be the same length. Straighten up the edges and make it square so you have a nice crisp cube. When you finish your cube, we'll use it as a scaffold and attach blue pieces that always go from the middle of one cube edge to the middle of another cube edge. These will make the 4 big triangles. Connecting the proper midpoints can be tricky, but you can use your paper model as a guide. And remember, each triangle connects a top point, a bottom point, and a halfway up point, no matter how you turn it. Again, always fold over the ends the same amount, and just clip them onto the cube edges. When you're done, you'll have 4 floating triangles. Each of the 12 cube edges supports 1 triangle vertex. Look at it different ways, and I think you'll find it's a beautiful little structure. Be sure to observe how any 2 triangles are linked like a chain. Once you get to know it, you can make it in any materials you like. Here's a version made of colored sticks cut out and glued together. See what materials you can use to make one.